recording. And I'm going to share the screen. Yes, so I've shared my screen and I assume that, yeah, it is visible. Okay, so here's the first question. Let's just understand the question first. It says, Gia has to solve the equation 2 minus 2 sine square theta equals cos theta, and the range for theta is from minus 180 to 180. Gia's working is as follows. All right, so Gia did some working. Gia's teacher tells her that her solution is incomplete. Yes, this would be one of the answers, but it is not complete. Okay, explain two errors that Gia has made. So it is a 2-mark question. Just know that it won't be something very technical or very difficult, right? Yes, so let's look at it. So this is what the question looked like. For the second step, she just used sine square theta, and we know that sine square plus cos square is equal to 1. So this is what she has used. Sine square would be equal to 1 minus cos square theta. So here she has plugged in 1 minus cos square theta. All right, then she just did some simplification, and yeah, once she was at her third step, she cancelled out this cos theta with the power 2 and she was left with this. So what do you think? Is this thing correct? Should she cancel this, or what should have been a better choice in this case? Okay, now I'll tell you. So yes, obviously if she's cancelling it, that is correct. That is not wrong. But this way she would be missing out a solution. Okay, so she could have done this step this way, that 2 cos square theta, this was the step, equals cos theta. Instead of cancelling cos theta, she could have done it this way, 2 cos square theta minus cos theta equals 0. And now she can just take cos theta common, and you will see she would be able to find multiple solutions this way, which she was not otherwise. So 2 cos theta minus 1 equals 0. Now she is getting cos theta equals 0, and she is getting 2 cos theta minus 1 equals 0. And now when we'll simplify this, this would become cos theta 1 by 2. So since she cancelled out cos theta with cos theta, she did not get this. So this was her first mistake. Do you get this?
Yes.
Okay, very good. And then the second one is, because we were supposed to find two errors. So this was the first one, because whenever you have a quadratic equation, we are never ever trying to cancel x with x. Okay, x square with x. We know that we need to factorize and then do it. So same strategy is used here as well. All right. And then for the last one, okay, now theta is equal to 60 degrees. That is 100% correct, but it is incomplete because this is your range and you need to think inside this range. Let's talk about the 4 quadrants we have. So when we talk about trigonometric solutions, trigonometric equations, we talk about quadrants. Okay, so in the first quadrant, sine, cos, tan, all of them are positive. In the second one, only sine is positive. In the third one, only tan is positive, and in the fourth one, cos is positive. So what do we have? Cos theta equals 0 would give a solution. Yes, this was the first error. Now we are looking at this equation. Okay, so we see that cos theta is positive, so it would be in the first quadrant and it would be in the fourth quadrant. The answer for the first quadrant is there already. It is going to be 60 degrees, and we do have the fourth quadrant as well. What does this range means? This range means from 0 to 180 degrees. So we'll start from here and we'll go till here, and then from 0 to minus 180 degrees. So when we have minus 180, we go in the clockwise direction. So this would be the range, and we do have the fourth quadrant in that range. So Madiha, can you tell me the angle in the fourth quadrant? Yes. Can you hear me?
Yeah.
Okay, so can you think about the angle in the fourth quadrant? All right, now I'll tell you. So basically, whatever angle is coming in the first quadrant, we need to keep that as the standard. Okay, we use that every
Yeah.
time for all the quadrants. So it is in the fourth quadrant, but it is not from 0 to 360 degrees. If it was 0 to 360 degrees, this would have been an anti-clockwise angle. It is from 0 to minus 80 basically, right? We are going in the clockwise direction. So the angle in the first quadrant was 60 degrees. This is also going to be 60 degrees. But since the direction is going to be opposite, so it would be minus 60 degrees. So this is what she missed. It would be minus 60 degrees. She missed this. Yes. Did you understand this question?
Yeah.
All right, very good. Okay, so since it was a 2 mark question, there's no point in doing all of this. No, first you need to write down this thing that she shouldn't have cancelled cos theta with this. That was the first error. And the second one was this, that cos theta is positive. It is also positive in the fourth quadrant. We have fourth quadrant in the range as well. So this was missing. That is it. All right, very good. Okay, now let's talk about this part. So it says write down all the values of theta that satisfy the equation. This is the same equation. These are the two equations. I'll write them down again. Cos theta is 0 and cos theta was 1 by 2. So we already got theta equals 60 degrees and theta equals minus 60 degrees. This is clear. But what about this one? When is cos theta 0? When is the value of cos 0?
Equal 60.
Theta 90. Okay, theta 90.
How do you know?
Okay, either you can use your calculator. If not your calculator, then you can use the graph of cos theta. Okay, so it's starting from there, then it goes up like this and this. So this is 90 degrees. So this is cos theta, and cos theta is 0 at theta equals 90 degrees. But here you can just do cos inverse 0 and make sure that your calculator is in degree mode because the angles are in degree, and you will get 90 degrees. Just check that.
Cos minus 1, is it?
Cos inverse 0.
Yeah.
Okay.
Okay. Yeah.
Okay, very good. But
Yeah.
yeah, okay, so one angle is turning out to be 90 degrees, but whenever you have a range, you need to think about all the possible angles. So what and other angles would there be for this thing? So if I just extend the graph this way, I know that if I make the graph of cos properly, it would be of this type, and it is also 0 here. So it is 0 at 90 degrees, it is 0 at 270, it is 0 at minus 90, it is 0 at minus 270. But since 270 and minus 270 are not in our range, so we only have 90 and minus 90. So minus 90 would also be written, minus 90 degrees. And whenever we have cos theta, sin theta, tan theta equal to 0, you can't really refer
Yeah.
to those quadrants, because in those quadrants, the only
Yeah.
information we have is that if it is positive or negative. Okay. So for 0,
Yeah.
you can use your calculator or you can use these graphs, because we need to know the plotting as well for the basic shapes. So that is important. Okay. So I would suggest for such cases where we have 0, always try using the graph and you would get the correct answer. Okay, so we would have these 4 answers: plus minus 90 degrees and plus minus
Yeah.
60 degrees. All right, very good. Let's talk about the third part if we have. Okay, no, that is it. Okay, this was the first question and it was about trigonometry. Any doubts with this?
Is it AS trigonometry?
Yeah, it is AS trigonometry. I made sure you just send me the paper code and everything, so this says AS trigonometry.
Oh, we've not done AS trigonometry yet.
Oh, that's why. But it is okay. You would be giving the exam,
Yeah.
right? It's okay. It's don't think about
And
it. You won't be giving pure maths exam.
No, because I don't think we're going to cover it at the end of the year, so I'm not sure.
No, but what subjects would you be giving in this May, June?
Oh, it's going to be everything we've done so far, like the logarithm, vectors, and all the
No,
stuff
no,
I
like
didn't
you know,
do.
if you are giving the board exam, so obviously they would give you everything, no? Like they would just give you a paper. Would you be appearing for the AQA board exams or just for your school exams?
It's full exam.
Oh, but then when will you be appearing for the AQA board exams? That is my question.
Oh, that's next year. That's year 13.
All right, all right. Okay, okay. That is okay. That is okay. But yeah, it's good that we understand. But I am sure that you have understood this, no?
Yes. Yeah.
Okay, very good. All right. Perfect. That's really good actually. Okay, but then some of the other questions are very easy as well. So don't worry about it, okay? Okay, let's talk about this. It says it is given that f of x equals x cubed minus x squared plus x minus 6. Use the factor theorem to show that x minus 2 is a factor of f of x. All right. Now we have a factor theorem. It's very simple. How do we use factor theorems? Okay. Now this is a cubic equation. Okay, we know when we have quadratic equations we end up getting two factors. It is a cubic equation and they want you to show that x minus 2 is a factor. Now for these questions we have one fixed method. Okay, do you know what factor theorem is exactly?
Yeah, we've done the factor theorems, yeah.
All right, okay, so you have done that, right? So if
Yes.
x minus 2 is a factor, we will use x equals 2 in
Yes.
f of x. F of x
Yeah.
is x cubed minus x squared plus x minus 6. This is f of x. I will plug in 2 in x and see that this
Yes.
would give me 0. So
Yes.
2 cubed minus 2 squared plus 2 minus 6. You can just check, it would be 8 minus 4 plus 2 minus 4. Minus 6, sorry.
Yes.
All right, so this would give you 4 and this would give you minus 4 and this is going to be 0. So since after plugging in 2 we got 0, this is what factor theorem is, and
Yes.
certainly it would be a factor. All right,
Yeah.
perfect. Okay, now for the second part, it is just a 1 mark question. It says find the quadratic factor of f of x. Now you know if it is a cubic equation, it would be having 3 linear factors or 1 linear and 1 quadratic, right? Because the power is 3. So we need to find the quadratic factor. Okay, how do we find it? So we do it by long division. Okay,
Yeah.
let's do it. Can you try doing it?
Yeah.
You can try doing it, and if you're getting the right answer, that's perfect. If not, then I'll do it for you. Yes, Madhiha, are you able to do it?
Yeah, 1 second, later.
Sure, sure.
Is it x squared plus x plus 3?
Yes, very well done. Excellent. It would be the quotient would turn out to be x squared plus x plus 3. Very well done. Yes, perfect. Okay. So that is how we will find the quadratic factor, and this is going to be the quadratic factor. Very well done. Okay. Now this is the third part. It says, hence, show that there is only one real solution to f of x equals 0. Now this is f of x. We know how to find solutions, right? Instead of writing down that cubic equation, I can write it down as a product of this linear factor and this quadratic factor. So it would be x minus 2 into x squared plus x plus 3. Okay, we have everything in front of us, so we don't need the previous parts. Let's do it. We need to show that there's only one real solution of f of x equals 0. So I'll just rewrite this as x minus 2 into x squared plus x plus 3 equals 0. So this would give me x minus 2 equals 0, and this would give me x squared plus x plus 3 equals 0. So one solution is very clear. It would be x equals 2. This would be one solution, and the other solution would come by either doing middle term breaking for the quadratic equation or using the quadratic formula. But the fact it says we need to show that it has one real solution only. So it would be that for the second quadratic, for this quadratic equation, there won't be any solution. So when we say no real solution, what do you think? What comes to your mind? There's just one thing which comes to our mind when we say no real solution, that the discriminant b square minus 4ac would turn out to be less than 0. So b
Yeah.
is 1, minus 4, a is 1, and c is 3. So this would be 1 minus 12, that is minus 11. The fact that it is less than 0 implies no real solution from this quadratic equation. So this would only be the solution, and that is how we prove this. Yes, is that okay?
Yes.
All right, very good. Let's talk about the next part of this question. Here it is. Okay, it says, find the exact value of x that solves this. Okay. Now, if you look at this question initially, anyone would think about it as a difficult question because it looks like you have exponential in this and how to solve this and stuff like that. So if it is genuinely a difficult question, it won't be for 3 marks. Okay, like if you're thinking that it would be you'll be doing it through a long method and stuff like that, so it won't be for 3 marks, and this means you're thinking in the wrong direction. The fact that it is D part of a question means that it is coming somewhere from the upper parts, right? Let's scroll out and let's see what exactly f of x was. So I'll just write down f of x and then we'll talk about it. So f of x was x cubed minus x squared plus x minus 6. Okay, and we have recently solved a few minutes back x cubed minus x squared plus x minus 6 equals 0. So can you find any similarity between the two equations I've written? Okay, 0 and 0 is same,
Yeah.
minus 6 and minus 6 is same, but this is not
The
same,
point.
this is
Yeah.
not same, this is not same. So this means there's just one thing which is different. Let's think about that one thing. What if I claim that x is equal to e to the power x? Okay, so let's try writing down this equation again. Since
Yeah.
x is equal to e to the power x, it would become e to the power x cubed minus
Yeah.
e to the power x squared
Yeah.
plus e to the power x minus x equals 0. And we know that when we have two powers, one is here, one is here, and if the other one is outside the bracket, the powers are multiplied. Okay,
Multiply.
very
Yeah.
good. So it would be e to the power 3x minus e to the power 2x plus e to the power x minus x equals 0. So finally we know that there's a link, and this is the link. This is what we need to understand. All right, perfect. So we were able to find the solutions for x in the previous part. When we were showing that it has one solution only, we were actually finding solutions for x, and it was x equals 2. Okay,
Yes.
so the fact that x is equal to e to the power x, and for the previous part x turned out to be 2, this means we can use them. I can write it down this way, that e to the x equals 2. And now I need to solve this. So how do we solve this? Now x is in the power, this is e, we can take natural log on both sides. So ln e to the power x equals ln 2. Okay, in maths we can do anything as long as we are doing it on the both steps. And we know that natural log with exponential is basically 1,
Yes.
right? So it would become x equals ln 2. And this is going to be your answer. Yes, is that okay? All right, okay, very good. So we are done with the second part as well. Let's talk about the third one. Now this is very interesting question. It is actually very easy, but initially it looks a bit challenging. Why? Because it is a 5-mark question. Okay, let's understand it. The diagram below shows a circle and 4 triangles. So we have a circle and we have 4 triangles. Okay. AB is a diameter of the circle. C is a point on the circumference of the circle. Now this line is extremely important, and it was obvious as well, but the fact that they are writing it down means it has something to do with the solution. The triangle ABK, BCL, and CAM are equilateral. Another important piece of information, since they are sharing it, that was not obvious, so it means this would be used as well. Prove that the area of ABK, A, B, and K is equal to the sum of the areas of the triangle BCL, so the small triangle, and CAM, and then CA and M. So basically the sum of this triangle plus this triangle equals to this triangle. So yes, now I'll just give you an idea. This would be used. Okay, we know that if a triangle is equilateral, all the sides are equal, and we know what would be the angles, right? What would be the angle? Since all the sides are equal, so in any equilateral triangle of this world, every angle is 60 degrees. Okay, even if the triangle is small, it would be 60 degrees, and all the angles inside these equilateral triangles would be 60 degrees. That is it. Now think about it, and I'll give you 2 minutes, and then tell me if you were able to prove it or not. I'm here. If you have some issue, you can ask me directly. Okay.
Like,
Yes, Madiha. Any luck with the question?
Yeah.
Okay, all right. So I'll wait.
I'm stuck.
All right. Okay. So can you tell me like in which direction you were thinking exactly?
Is it because for the triangle ABK,
Yes.
is it going to be AB times root 3 over 2 AB times a half?
Please say it again. I missed it. So you did half AB into what?
No. AB
Hmm.
times root 3 over 2 AB times half equals to root 3 over 4 AB squared.
For what exactly? For finding the area?
Yeah, of triangle ABK.
Okay. All right. And then.
And then the area of triangle BCL
Hmm.
is going to be BC times root 3 over 2 BL times a
Hmm.
half, which equals
Hmm.
to
Hmm.
root
Hmm.
3 over 4 BC squared.
All right. All right. Okay. Okay.
And then I did the same for
For AMC as
the
well.
yeah,
All right. Okay. Yes. We would be using the same formula for area. You were going in the right direction. Okay. Right. But before that, let's say you were doing this question and exam and you were
yeah,
clueless, you did not know how to do it. Forget about the question.
yeah,
Okay. Let's just see that why are they sharing this much data, this much information? Because they want you to think in that direction. So I won't be talking about the question. Let's use this. AB is a diameter of the circle and C is a point on the circumference of the circle. So
yeah,
can you think of some property with this? If it says angle at circumference is half the angle at center, stuff like that, this would be the center. So this
yeah,
angle is 180 degrees because it is a straight
yeah,
line, and this is
yeah.
going to be 90
The,
degrees. Okay, so
oh,
this
half
is
degree.
a right angle triangle.
Yeah,
All right, that is perfect. Okay, now why exactly? What is the significance of this right angle triangle? The significance of this right angle triangle is this, that I can write down the side AB in terms of AC and in terms of BC. So I know that the longest side square is equal to the square of two small sides by Pythagoras theorem, right? This is what we know
yeah,
through Pythagoras
yeah.
theorem. Very good. All right. Okay. I was just writing it down. Okay. This is the first thing. And then the second thing is that since all of these three triangles in which we are interested are equilateral, so this angle would be 60 degrees, all the angles would be 60 degrees, and you know this and you were able to think about it in the right direction. Now, The only thing where you went wrong was you were picking up two different sides. The fact that this side would be equal to this side would be equal to this side means that if I'm interested in writing down the area of A, B, K, I can write it down as half, then the product of two sides and third angle. Okay. So whatever the sides I'm taking, I know all the sides are equal and all the angles are 60 degrees. So I can take AB into AB, because even if I'm taking BK or even if I'm taking AK, that would be equal to AB actually, right? So I can write it
Yes.
down as AB squared into sine of 60 degrees. I don't care about which exactly two sides these are. The fact that all the angles will be 60 degrees, all the sides will be
Yeah.
equal. So this is perfect. All right. This is for the area ABK. Then we can write down similar expressions for the area of BCL. So it
Yeah.
would be half, and then we would not be talking about BL and LC, because we know there's a relationship between AB square, AC square, and BC square. So I'll stick to the side BC, and I know that we need two sides and the third angle, but the fact it is an equilateral triangle, so that thing does not matter. Half BC square into sine 60 degrees. Okay. And then the third one would be area of CAM. That, can you tell me what would be the formula?
Half.
Very good.
Would it be AC?
Well done. Okay. Because you can see that there would be a link with it. AC
Yeah.
squared and sine 60 degrees. All right. Now we need to prove this. We need to prove this. So for proving anything, we need to start off by taking either sides. Okay. So what we can do is we can just write it down this way. Area of ABK is equal to, we'll prove this, the area of BCL plus the area of CAM. We need to prove this. We are not writing it down. We'll prove this because at the end. Now, you know what? In the demo class, when I was teaching you, I told you for proving things, we have multiple ways. Either you can
Yeah.
just start with left side and make it look like right side, or you can start with right side, or you can start with both of them, and at the end whatever you're getting would basically be some equation which is true in general. Okay. Area of ABK turned out to be half AB square and then sine 60. I'm writing it down as it is, and then area of BCL was half BC square and then sine 60. And then area of CAM was half AC square and then sine 60. Now I can clearly see that on the left hand side, half and sine 60 are coming common. So half AB square sine 60 degrees, and here half is coming in both of the terms, so I can take it common. Sine 60 is coming in both the terms, so I'll take that common as well, and I'm left with BC squared plus AC squared. Now it is the time to cancel out things. Sine 60 and sine 60 can be cancelled. Half and half can be cancelled. And what are we getting? We are getting AB squared equals BC squared plus AC square, which actually exists because of the Pythagoras theorem. This is what we discussed in the very beginning. Okay. So since this is a right angle triangle and AB is the hypotenuse side and these are the two small sides, so we can apply Pythagoras theorem and this would be proved. So that is why uh, this happened. The area of ABK was equal to the area of BCL plus CM. Okay. So always remember, the best thing about this is that you're not memorizing anything. Okay. you know that
Yeah.
you have some things given. This could have
Yeah.
been a very difficult question if this and if this was not given. And they're not giving you too much information. They're just giving you limited information, which would certainly
Yeah.
be okay. So just if you're clueless, if you are not able to understand this part, just start thinking with these two, and then you would be able to make something out of it and do it. At least you would be able to get a mark or two, even if you are just using the what
Yeah.
do you say, the properties. All right, okay, so are you okay with this now? Yes, Madiha? Okay, all right. So let's talk about the next question. Okay, so it says an object is moving in a straight line with constant acceleration over a period of t seconds. It has an initial velocity u and final velocity v as shown in the graph below. Use the graph to show that v equals u plus at, and these equations are used for solving questions with constant acceleration. But you need to prove this, okay? So you have a graph, you need to use the graph. You know a property about graphs, that the gradient of velocity time graph is basically giving you acceleration. So you can find the gradient of the velocity time graph and equate that to acceleration and simplify this. So can you try doing this? Okay. Yes, actually I'm not able to hear you properly, but I assume that you said yes. So I'll wait and then you can just try doing it.
Would it be b minus u if, over t minus 0 equals to a, and then b minus u equals to at, and then b equals to u plus at?
Yes, very good. Well done. Okay. The fact that the gradient of velocity time graph is acceleration, you'll just find gradient, equate it to acceleration, and this is what you get. Very good. All right. So, yes, this is done. Let's talk about the next one. Okay. Now, so basically, I also wanted to talk about some mechanics questions, but then we have some pure maths questions again. So that this is a mixture of all of what we basically discussed together. So I wanted to talk about those questions specifically. All right. So it says, yeah, a particle of mass 0.1 kgs is initially stationary. A single force F acts on this particle in a direction parallel to this vector. As a result, the particle accelerates in a straight line, reaching a speed of 4 meter per second after traveling a distance of 3.2 meters. Find F. Okay. F is a vector. We know that when we talk about vectors, magnitude and direction, both things are important. Okay. So you can use Newton's law and find the force, and then you can use this vector to find the direction. So again, I'll wait for a minute or so. I would want you to understand the question first, think about it, and if you know the working and stuff like that, you can just share that and then we can do it together, okay? Yes. Any idea, Madiha?
Yeah.
All
Once
right.
again, maybe solved it.
Very good. Very good. Okay, perfect.